This is our notes on area of a rhombus. So our formula is 1/2 diagonal 1 times diagonal 2. So essentially we're just multiplying the diagonals together and then taking half of that, and that will give you your area. But it's really important to remember a couple of the properties about rhombi. One of those is that the diagonals bisect each other, so they cut each other in half, and the diagonals are perpendicular to each other, which means they form right angles with each other, and the diagonals also bisect the opposite angles. So it's important to remember those things. So for example, if I drew in the two diagonals in this rhombus, here are some things that are happening. These 4 angles in red are now the same. These 4 angles in blue are now the same. They are perpendicular, so there are right angles in the middle of that rhombus, and they bisect each other. So these 2 segments in green would be the same, and those 2 segments in green would be the same. So that's important to remember as we're looking at the rhombi. So for example 3, we do know that this is a rhombus, and we know one of the diagonals is 82, and we know one of the angles is 108. So because we need to know both diagonals, it's very important that both diagonals are drawn in. So the first thing we need to do is draw the other diagonal through the rhombus. And you might be thinking, well, Miss Angry, you just drew through the one angle we knew. But that's okay in this case, because what happened to that angle? It just got split in half. So now those 2 angles are 54 degrees. When we drew that other diagonal in there, we also cut the existing diagonal in half. So now this side is 41 and this side is 41. We also know that right angles were formed in the center when the diagonals intersected. They're perpendicular. So our goal is to find that second diagonal that we just drew in. And what's nice for us is we have 4 little right triangles inside of this rhombus that we can work with. So here is a green little right triangle, and in that triangle, we know the angle is 54. We know the opposite side is 41, and we want the adjacent side. We want this orange side that I'm highlighting because that's going to be part of the diagonal that we need. So we are using trig. We are using tangent specifically. So tangent of 54 equals opposite over adjacent. The variable is in the denominator, so we can do the switcheroo trick. And that goes in your calculator, and you will get 29.8. But that's only half of that diagonal. We have to multiply that by 2 to get the whole diagonal. So 29.8 times 2 is 59.6. And the other diagonal was already given to us in the problem. It was 82. So we are ready to go with our formula here. 1/2 of the diagonals multiplied together. And we should get 2,443.6 squared centimeters. All right, so example 4, we don't have either of the diagonals drawn in, so that would be our first goal. So there's one of the diagonals. Here's the second diagonal, and think about what just happened as you drew that diagonal in. That 60-degree angle got split in half. Right angles were formed in the center. These 2 segments are congruent, and so are these. So now, because this is a rhombus, we're told that one of the sides is 8, but we actually know that all the sides are 8 if it's a rhombus. So we're going to use these little right triangles inside to help us get the diagonals. We don't have either diagonal at this point. So in that little green right triangle, I have a 30-degree angle. So we are going to use our 30, 60, 90 rules. And we have the hypotenuse, which is 8. So we always have to find short leg first. So hypotenuse to short would be divide by 2. So that is 4. So that makes your first diagonal 8. And then we need to go short to long. Short to long is multiplied by root 3. So 4 times root 3 is 4 root 3. So those are each 4 root 3, which makes your second diagonal 8 root 3. Now we're ready to roll. 1/2 of 8 times 8 root 3 is 32 root 3, and that is square feet.